Hi, I'm Tom Longo from SPAL, and we're here with our friends at Old Anvil Speed Shop in Orange, California. Today we're going to work with Paul Bosserman and go through the steps on how to program a SPAL Brushless Fan using an ECU. Let's go find Paul. Hey, we found Paul. Hey Paul, thanks for doing this. I really appreciate it. Why don't you tell us who you are?
Hi, I'm Paul Bosserman from Old Anvil Speed Shop. Electric fan technology has come a long way, but it's hard to find good info on how to install and program brushless fans. So for this video, we've partnered up with SPAL and DeWitt's to tell you everything you need to know about installing and programming these modern brushless fans using a Holley Terminator X or Dominator ECU. So to give you a little background on our test vehicle, we have a 1974 Triumph TR6 that we've been working on for many years. We just wound up putting an LS in it to go to LS Fest for Holley's LS Fest West. And it's tight space, we really needed to cool it. So we went to DeWitt's and SPAL to see what we could come up with. We had to make a few modifications to a Corvette radiator, and we got that to fit. And then we went to the brushless fan, and it worked great. So here's how we do it. So let's talk about the wiring. The SPAL brushless fans come with this harness already made up. They have great plugs. They're super heavy duty and they plug up so simple. And it's a real simple hookup for us. It's basically a 3-wire system. So you have your battery positive, battery negative. This is for our signal from our ECU. And then the yellow wire is not used for this application. The white wire can control multiple SPAL brushless fans from the same output. Just note that the PWM programming will control all the fans at the same time. So once you have these hooked up, then we'll move on to programming it. So to start off, we're going to assume that you already have your Holley Terminator or Dominator set up. So what we're going to do is show you how we go in to program it. So for our application, I'm going to go into the Terminator X software. We're going to open up a file. Actually, we're going to create a new one. So we're going to go into base calibrations. Let's go GM, LS based, and we could basically pick any of these. So we'll just do a 24X 4L80 multi-port fuel injection. So this is a tune that Holley already has set up for you. So now we're going to show you how to go in. First thing you need to do is go in, if you don't already have an input-output, just go into your toolbox, add individual configuration, and we'll do inputs and outputs, and we'll click on the default. So if you double-click on that, it'll load it. So now we have this little icon, the input-output. We can pull that down, and that gives you inputs, outputs, and inputs, outputs. So we need to go to outputs. And under outputs, we'll create a new file name or a new name for this, and we'll call it the PWM fan. After that, we go to our type. So type is the type of output we want. So for this application, we'll want to do a PWM. I guess first we have to enable it. So we'll enable it. So now we can pull down that menu. We want the pulse width modulation, PWM negative. What that does is it basically takes a ground output and will modulate it. So we're going to click on that. It's asking you if you want to do this. We say click OK. Now we want to go to configure. This box will open up for you. We go to configure. We have different options here of ways to cut this thing on. So they have switched input triggers. We're not going to use that on here. You could turn it on and use that to turn on your duty cycle. But we're going to go to sensor input triggers and go OR. So because we're going to use a sensor and not a switch. Under that, we're going to do 1. This output will activate when. So for this, there's all different ways you can tell it to use this. We're going to go RPMs above 400 RPMs. So basically this is going to tell it to only run when the engine is running. But you can use whatever trigger works best for your application. Then from there we go up to our PWM setup. All right, so now we're going to create our table. To do that, we're going to set it at a fixed type, and our frequency should be anywhere from 100 to 128. That's in hertz. That's our basically our square wave of that will output to the fan. So we're going to set that at 128 hertz. And for table units, we want to use our duty cycle. Then we have our X and Y axis. So the X axis we want to be our coolant temperature switch. So we will change that in here to coolant temperature switch. And that will give us, according to the temperature that it's running. And we'll start at, say, 0 degrees. And then we're not going to, for what we're doing here, yours might be different. We're going to start at 160 degrees is where we actually want to start changing what the fan does. So we'll go from 160, and then at, we want to kind of max out at 210. So when it gets to 210, our fan will be maxed, and then we'll set our top number, we'll set that at like 260. That could go higher. I don't think the engine would ever get that high. If we do, we got catastrophic failures. But let's go 300, just to say. All right. So the way this thing works is what duty cycle we're telling the fan it needs. It's kind of opposite in numbers. The fan will cut on at 85% duty cycle, and it'll be wide open at 8%. That's the range that we want to use for this fan. When we put 0 duty cycle in there, the fan will be off. So we're going to leave our first column at 0. At 160 degrees, we want to fill this in at 85%. And then at 210, 8 degrees should be full blast. So we will highlight both the 210 and 300 degree, and we'll put in 8%. That way the fan's maxed out, and there's a little bit, like I said, there's a little bit of variable, but that ensures that 8% that the fan is running wide open. So then we can fill in those values in between. And this is showing you basically how this works, how the tables work. So now we're in a variable. So the reason I'm doing it like this, we want our optimum temperature in this engine to run at 180 degrees. So we're just kind of guesstimating here to actually go tune this. We could actually tune the fan to the car, and so it'll be different for different cars, but ideally we're going to try to be around 50% fan at 180 degrees. So here at 179 on our table, we are at 55% duty cycle. So you can see the variable going from there to full blast. So as we get up in the 200 ranges, now we're getting close to full speed. So the fan's working much harder. And of course, every engine's going to be a little bit different. What you want to run, you may have if it's a stock LS, you're probably going to be up around 210 is the running temperature. So maybe you want it to cut on full blast a little bit later yet. But for ours and our high performance applications, we like to run 180 and everything. So after you got your table built, we'll go to the pin map, and we should have on our outputs, here's our PWM fan speed. Of course, we also have the speedo. So in here, the Holley defaulted at electric fan 1, electric fan 2 are ground switches for B12 and B11. So what we're going to do is we're going to take and pull this one out because we don't need that. And now we're going to use what the P negative here. That means the pulse width modulated output. So we're going to take our PWM fan that we created, put that in that slot. So now pin B12 on our ECU output, this works for both Terminator and for the Dominator systems. That output is now a pulse width modulated signal that will hook to our white wire on our fan. So it's that simple. You just basically connect that white wire to your pin that you've designated here in your connector, and you're good to go. So there's one more thing. If you want to get rid of where your electric fan is, you go back, because I know this was generated automatically. Basically under your system ICF, you have basic inputs and outputs here, and you can see there's fan 1 and fan 2 are on, so we'll click those as off. We won't, this part of the Holley system is not, it's not needed if we're using our pulse width modulation, because we created that in a whole separate inputs and outputs. So it's pretty neat. This is pretty powerful stuff. The things we can do. If you have any questions, you can talk to somebody at SPAL or Holley, and I'm sure they can send you on your way of how to get to what you want to do. But this is a pretty neat system. Okay, I think that ends what we needed to show you on how to program this thing. So let's get it installed and see what it does.
Well, thank you very much, Paul. Really appreciate the time.
Yes, sir.
It was really helpful. I think people are going to be able to learn a lot from this and be able to program their ECU. What do you think?
Oh, this fan is incredible. It's a game changer for sure.
Well, that's what we're planning on doing here. Thanks.